Good morning, students. Now we are going to discuss on kernel in Unix. So this topic, which is going to be an very important one, and the basis of operating system. So whatever the operating system that you people are going to use, in all those operating systems, you will have this kernel. This kernel, which is going to be acts like an internal core of your operating system. So this internal core, which consists of some various subsystems and various main systems. So using these main systems and subsystems, we are going to control the entire operations of your operating system. So here we are not going to deal with the main systems, but we are going to concentrate on what are the various subsystems that we have in kernel. So here especially we are going to concentrate on Unix operating system. So as already I discussed, we have various operating systems. In all those operating systems, we have kernel, but here we are going to concentrate on one particular operating system. The operating system here that we are going to discuss is kernel, Unix operating system. So I am going to cover some various things in this presentation. The first I am going to discuss on what are the various key components that we have in Unix kernel systems, and then I'm going to concentrate on various subsystems that your Unix kernel structures that it have, and then I'm going to concentrate on what are the various basic services that your kernel it used to provide, and finally we are going to discuss on what are the various key components, basic services, and their interactions with system calls and libraries that you have in your Unix kernel systems. So in the introduction part, we are going to discuss on the core and key components of your Unix operating system. So this consists of some various kernel subsystems like process management, memory management, file management, and device management, and finally about network management. So these are the various subsystems that we have related to kernel in Unix. So based on this key components only, your operating system it used to work. The first one about process management. So whatever the process that you're going to do in your operating system, all this process will get controlled using this process management. So the process, which means whatever the action that you're going to perform in your operating system. So suppose we are going to open a file, or suppose if you're going to open a document, or suppose if you're going to use a browser, or suppose if you are going to use some other softwares whatever that you have in your operating systems, all those things will be like an collection of a process or sub process or like a task whatever that you're going to do. So for all these things, you need the support of this process management. Without the support of process management, we won't be able to do any actions or any executions in your operating system. Next one, which is about memory management. So the process management is very important, and then the memory management is equally important while comparing to your process management. So the memory management, which consists of some various parts like primary memory and secondary memory and the additional caching memory. So how we are going to manage this memory? So whenever that you're going to execute a process, how we are going to take a process, and then how we are going to put those process into the memory, and how we are going to execute that particular process by placing that particular process in memory. So that's about memory management. And then here we used to move that particular file or process between the primary memory and secondary memory to primary memory. So these types of movements generally we used to call it as in swapping process. So these swapping process will be discussed here in this memory management. And next one, which is about file management. So you'll have some collection of files in your operating system. So how we are going to hierarchically arrange those files, and what is the structure that we're going to give, and how and what basis that we're going to access, and what is the various path that we have to access a particular file. So that will be discussed in file management. And device management, which is about what are the additional devices that your operating system which is going to support. So those additional devices and their interactions will be discussed in device management. And finally, about network management, the Unix operating system which supports networks very well. So whatever the process that you're going to do related to networks, so all those will be get managed using this network management. The next one we are going to discuss on Unix subsystems. So in this Unix subsystems, we have some four subtopics. The first one is concurrency, second one is virtual memory, third one is paging, and fourth one is virtual file system. So concurrency is the ability of the operating system to do some concurrent operations at the same time. So concurrently, it would process some n number of files, or it used to execute some n number of softwares, or which used to helpful to us to measure the performance of your operating system. So normally to execute some multiple process, we used to use this term concurrency. The next one, which is about virtual memory. Virtual memory is the one which is going to be acts like an backend memory space. We may not know when we are going to use it, but some situations we won't have some sufficient memory spaces in your computer. So at those times, we used to access this virtual memory, and by placing the files or softwares in this virtual memory, we used to execute your programs. So we won't worry about what is the program size, or what is the structure of program, or what is the capability of program that we're going to execute. But by using this particular concept named as virtual memory, we used to execute a file of any size that you want to run. The next one, which is about paging. Paging, it is the one which is going to reduce the fragmentation process both internally and externally. So you people know about fragmentation. So fragmentation, which is one which is going to be an additional memory spaces that you have in your disk spaces, which is not going to be an additional one, or which is going to be fragmented like an extra spaces between one file and another file. So somehow we have to remove these extra spaces, or the fragments whatever that we have as in disturbances between one file and another file. So these fragment will be removed using this process named as fragmentation, using this paging as a technique. The next one, which is about virtual file system. So using this virtual file system, we would be able to manage the complexities of the files, its hierarchies, and its accessing mechanisms. So whatever the files that you're going to use, and whatever the file formats that you're going to use, in all those files and in all those file formats, would be able to access and execute using this virtual file system. The next one is about what are the various basic services that we have in your Unix kernel system. So the kernel, which is to provide some services like interrupt handling, and then managing the user and system space, and then about system calls and libraries, and scheduling, and then which is about file descriptor management. So interrupt handling, which means you are executing something, and whenever some additional disturbances or unwanted disturbances, or some whatever the immediate occurrence of any possibilities of systems that you have. So those things we used to call it as an interruption. So sudden interruption which used to occur during a normal execution of your system. So how we are going to manage this interrupt, and how we are going to process this interrupt, on what basis that we are going to manage these interrupts. So those things will be discussed here. And next one is about system calls and libraries. So we used to have some collection of system calls. System calls is nothing but what are the functions that we're going to use as an libraries to access various services whatever that we have in this Unix operating system. So to access those system calls and libraries, we used to use this kernel as an important services. And we have some separate user space and system space. So the user space must not disturb the system space, and system space must not enter into the user space. So how we are going to separate it and how we are going to manage it. And then which is about scheduling is nothing but so always whenever we have to execute something in your operating system, we used to execute on the basis of FCFS, first come first serve basis. But using this scheduling as an option, how we are going to prioritize the process whatever that we have in the queue of your operating system. So that will be handled using this scheduling and clock handling option. Next one is about file descriptor management. So file descriptor is nothing but a pointer or string or a handler which used to access the file and which used to execute the file and which used to store some various permissions of the file. So which is going to act like a data structure for us. So these are some of the services that we have related to Unix kernel system. And then as already we have discussed the subsystems of Unix kernel services like process management, memory management, and file management. To this we have one more thing named as input output management. So whatever the input that we are going to get, your operating system is going to get, and how it is going to process, and what is the output that is going to produce, and where we're going to store those output. So those things will be discussed in this input output management. All these subsystems would interact with each other based on some system calls and libraries. So using those system calls and libraries only, just to pass some messages between these management various subsystems, and it used to process something in your kernel Unix systems. So here they have given some examples like accessing a database, and then printing a report, and then managing an emergency system. So all these things which seems to be like an example for how your subsystems used to interact and produce and appropriate results to the action that it's going to handle. And then the next one, which is about software libraries and system call interfaces that we have. So system call interfaces, in the sense we are going to use some function, and to this function we are going to pass some parameters. So based on the parameters that used to pass, it used to do some actions, and after performing those actions it used to produce some results. So here we have some various services, and then we have some various subsystems. So these subsystems and services which used to interact with each other, and it used to produce some results. So all these things will happen using these system calls interfaces. So these are the things about system call interfaces. And then we have some various software libraries. So using those software libraries only, we would be able to execute these system call libraries. So this is about system call interfaces. And then the finally about the conclusion. So here I'm going to conclude that the Unix kernel, which consists of some core subsystems, and then which used to provide some basic services, various basic services, and then using some system call interfaces, these subsystems used to interact, and it used to produce some appropriate results of executions or actions whatever that used to perform in your operating systems. So with this I'm concluding this session. So Students, you people have to concentrate much on this particular topic, as Unix kernel, which seems to be a core component in operating system, and using this kernel only you would be able to manage or process or do anything in your operating system. Suppose you have to control something in your operating system, you have to learn more about kernel, and then its operation, and then various subsystems whatever that it have with it. So with this, I'm concluding this presentation. Thank you, students. Thank you for listening these presentations. Thank you.